Hello everyone. So in the last video, we have talked about the characteristics of a good algorithm. So from this video onwards, we are moving towards the topic complexity. So before moving to this topic directly, let me ask you something. How do you think that Google within 1 second searches billions of pages? Or say you are using one app that is working brilliantly, but the other app is hanging. Why is it so? So if you think it this way, that it is because of better algorithm as well as better complexity. So what are the two things we will be considering whenever we will be judging an algorithm by its complexity? We will be considering the first one as there might be some more things, but for the time being, we are taking two very important things. The first one is time and the second one is space. Why do you think that this two thing is very important? Because obviously, if you see, always we want to take a particular phone or we want to use something which is fast, which is giving us fast results in a better manner. Because we always, in these days, we are always in hurry. So we cannot wait for a longer amount of time. So we will be obviously using those things which are fast. And if you see this part, the second one, space. Because these days, if you really want to think about it, if you open up the YouTubes, there are so many videos. So to think or to know how to utilize the space, how to optimize the space, how to write or design an algorithm so that it takes less space is a big challenge these days. Because the number of people are increasing, and with that the space and all these things are also increasing. So that's why it is very important to take care of a particular algorithm's time and space while designing the solution for a problem. So let me come one by one. The first thing is time, or say the time complexity. So what do we mean by time complexity? Is it the runtime we are seeing in terms of seconds, minutes, or say hours? No, it is not. It is not that particular thing. So what is then it is? It is, suppose we have a particular problem, and based on the input size, we check how the complexity is getting increased. Say, whenever you are trying to solve a problem, suppose the problem I was stating in the previous videos, that you want to short, say you want to short this number 1, 5, 7, 3, 2, 9. You want to short in ascending to descending manner or whatever. So based upon the input size, how this particular thing will be taking your time. So this particular time complexity is measured based upon the input size only. So that is, for this case, suppose we have the input size as 1, 2, 3, 4, 5, 6. But in real life, the input size will be huge. It is not related to 6, 10, 12, 50, nothing like that. The number is huge. We need to always think, whenever we are designing something, we need to always think about the worst case scenario. You cannot design thinking, okay, there might be only 6 numbers, there might be only 15 numbers, there might be only 30 numbers. We need to generalize in terms of that so that it works fine for the worst case scenario, for a huge number of input. So this particular time complexity is based on the input. So how we can write that? For an example, if you want to write the time complexity is n. So what do I mean by n? That is, it is taking linear time. Okay, if I want to write it as n square, what do we mean by n square? It is taking quadratic time. Okay, so what do I mean by this thing? Suppose, say, the input size is 100. So if you see, for 100 inputs, for this case, it will be taking, say, the time complexity is around 100. But if you see, for n square, for 100, it will be 10000. So see how drastically it is getting changed. So what will be our target? Our target is very simple. We will be trying to design an algorithm so that it takes very less amount of time. If we have, say, 3 possible solutions for a problem, we will be trying to take that one which is taking the less amount of time. But obviously it doesn't mean that we will be taking a wrong solution. It has to be picture perfect from whatever be the input and what is the desired output, and all these things are satisfied, then only we are going to this particular solution or this particular case. Now the second one, that is space complexity. So what is space complexity? Suppose what are the extra space needed, okay, or what are the total space needed for your algorithm to run. So for an example, what are the parameters or what are the things that determines your space? That is, say, number of variables you are using, okay, how many stack or call stack is there in your program, or might be some other factors like extra array or anything that you might be using inside your algorithm. For an example, there is a sorting method that we will be seeing in the upcoming videos called merge sort. So this particular merge sort takes an extra array while solving the problem. What is the problem in this case? There are unsorted array, we want to sort using some algorithm. So if we use the thing merge sort, even if you do not know what is merge sort, you do not need to worry. I will be covering in depth in the coming videos. For the time being, just understand this thing. This particular merge sort uses some extra bit of space or extra array to solve the problem. So in this case, the space is increased a little for this merge sort. So what we'll be doing in the coming videos when we'll be analyzing the algorithms, or when we'll be understanding this complexity, times complexity, space complexity, how to measure and all these things, we will be, in the coming videos, we will be trying to make a trade-off. What do we mean by trade-off? Trade-off simply means we will be trying to see that, suppose for an example, merge sort is taking extra space. But is it worth it? That is, even if it is taking some extra space, is it running very fast compared to the other sorting algorithm? Then we might give it a thought. Okay, then even if it is taking some extra space, we might use it. So there would be a trade-off between time and space. Okay, so that's how we will be seeing that when to take space, when to take time, or something like that. For the time being, just before ending this video, try to understand this thing. Suppose an algorithm is running or taking n amount of time. Another is n square amount of time, another is 2 to the power n amount of time, and so on. So if you say this particular thing for small input, it doesn't, you might not be bothered. Suppose the value of n is equals to 1. Then what is the value of n? This particular thing remains 1, this also remains 1, and 2 to the power n is 2 to the power 1, that is 2. This is exponential running time, right? So now what if n equals to 2? Then it becomes 2, this becomes 2 to the power 2, that is 4, and this becomes 2 to the power 2, that is 4. When is n is equals to 3? Then this becomes 3, this becomes 3 squared 9, this becomes 2 to the power 3, that is 8. Now if you see, for suppose n equals to 100, suppose if you have seen for this value difference is not that much. But if you want to see for n equals to 100, then the first one n stays as 100. But n square becomes 10000, that is 10,000, and 2 to the power n becomes 2 to the power 100. It's a huge number. So as the input size is increasing, all these things matters a lot. And in our case, as we are seeing, that we always will be considering the worst case scenario, because we cannot say that we will be doing for the best case scenario. No, we need to always keep in our mind that we need to do it for the worst case scenario, so that it becomes an in general solution. So the thing is, suppose you are running it in a supercomputer, the computer is very fast. Still, if your algorithm runs in say 2 to the power n times, for huge input, that is for input size around 1 billion, that system will fail. So what we are trying to say, or what is the whole purpose of this video or whole purpose of this particular course? In our course, we first try to analyze what is the time complexity of an algorithm, what is the space complexity of an algorithm, and then we try to work upon that so that if we can find out a better solution. Can we somehow reduce the time? Can we somehow reduce the space? These all the things we need to see. What are the procedures, or what are the procedures to first check what is the time complexity of this thing? So there are so many methods, frequency count methods, there is Master's theorem and all these things. So we will be seeing this thing in the coming videos. And also after that, we will be trying to design algorithms so that it takes a little less time, or we will be seeing that how to reduce the time, how to reduce a bit of space. Even if we can do it for a little thing, then also the whole scenario changes and it becomes a very much effective solution. So that's it for this video. Thank you for watching.